The domain of a function is the set of all possible values that the independent variable can have, and that will give us a real value for the dependent variable. So basically, if you have a polynomial function like y equals x squared minus 2x plus 1, the domain for that function is all real numbers, because each value of x gives you a real number for y. But for this function, since it's a square root, and you know that the square root of a negative number is not real, then what you have to do is you have to make sure that what's in the square root is greater than or equal to 0. So you would actually have to solve this inequality to get the domain. And so if you solve the inequality for x minus 5 is greater than or equal to 0, then you would get the solution x must be greater than or equal to 5. So the domain of the square root of x minus 5 would be all numbers greater than or equal to 5. Now you do need to be careful though. Don't assume that all radicals are that way. If this had been the cube root of x minus 5, then your domain would be all real numbers, because the cube root of a negative number is a real number. But of course it was a square root, so we had to make sure that x minus 5 could not be negative. Now this is just a linear function. 3x minus 2 is a linear function, and its domain is also all real numbers, because each value of x gives you a real number for y. Now when you have a rational function, that is where you have a numerator and a denominator, you've got to avoid letting the denominator equal 0, because you can't divide by 0. So we have to figure out what makes x minus 2 equal 0, and we have to avoid that number. So if you set x minus 2 equal to 0 and solved it, you would get x equal 2. And that's the number we need to avoid. So the domain would be all real numbers except x equal 2. Let me go ahead and show you another one. Let's drop down here to this one, x over x squared minus 4. For this one, if x is negative 2 or positive 2, you get a 0 in the denominator. So for this one, you have to make sure that x does not equal positive 2 or negative 2. Now let's go back to this other square root. This is the square root of 9 minus x squared. Well, actually, you can't let x be a number greater than 3, because if x is a number greater than 3, then 9 minus x squared would be a negative. And you can't let x be a number less than negative 3, because if x is less than negative 3, then 9 minus x squared would also be a negative number. So basically, x has to be a number from negative 3 to 3. X can be negative 3 or 3, because you can take the square root of 0, and it can be anything between negative 3 and 3. So therefore, I give you it in interval notation using brackets. So any number from negative 3 to 3 would be in the domain for that particular function. And again, if this was a cube root, the domain would be all real numbers. So, it's just the even roots where you have the issue with your negative numbers inside the radical. Okay, now here on this graph, you can look at the graph and determine the domain by just looking at the values that x take on. Notice that x starts at 1, and then x goes through here forever and ever, and it covers all values greater than 1. So the domain here would be all values greater than or equal to 1. So that's the domain from a graph. Now I'll go ahead and throw in the vertical and horizontal line tests here for you as well in this domain lecture. A relation is said to be a function if no vertical line crosses it more than once. Well, you can see that this line here is a function because it passes the vertical line test, but this sideways parabola here is not a function because you can see that a vertical line crosses it more than once, so that's not a function. And also this picture here is not a function because the vertical line crosses it more than once. Now, as far as the one-to-one test, to test if a function is one-to-one, you can use what's called the horizontal line test. And so if a horizontal line crosses a function more than once, like here, you can see this line is a one-to-one function because the horizontal line only crosses it once. This we wouldn't even test because it's not even a function, and neither would we test this one. But even though this one here is a function, it's not a one-to-one function because it fails the horizontal line test. In the next video, I'll talk about function notation.